525 when we're done. In AP Classroom, this goes with section 1.14 or topic section, whatever it's called in there. It's topic 1.14 in there. We're going to look at vertical asymptotes. So we talked about the indeterminate forms, the infinity over infinity, the 0 over 0. So now we're going to look at something when we get number over 0, which, yes, when you just directly substitute in the 3, you're going to get 1 over 0, which is an indeterminate, does not exist. But when that happens, remember you have to do it from the left and from the right. If you know what the graph looks like, and this is a parent function, that can help you a lot. Even if you are not sure what it looks like exactly, we should know that when you get the 0 in the denominator, it's a possibility if you get does not exist, it could be a whole or it could be an asymptote, right? If it's a whole, how do we know when it's a whole? They cancel out, right? You get the same factors in the numerator and denominator. So then after you've canceled everything out or there's nothing to cancel out, then the zeros of the denominator is what gives you your vertical asymptotes, which tells us that at 3, we have a vertical asymptote. Okay? Make sense? So then that means since I have an asymptote on either side of the asymptote, as I approach from the left, I'm either going to infinity or negative infinity, when I approach from the right, same thing, right? I just got to figure out which way it is. So a couple of different ways you can do this. One thing is if we're coming from the left, that means I'm coming from numbers that are smaller than 3, right? So if I come from the left, then I would have 1 over, let's say, 2.9 minus 3, okay? And I don't care what the actual value of that is, but when I do that, is that number positive or negative? Negative, right? This would give me a negative number. So as I come from the left, this would give me negative infinity. If I do 1 over and I'm coming from the right, that's numbers bigger than 3. That's 3.1 minus 3. That would give me a positive number in the end. So then this is positive infinity. Does that make sense to you? Now, the other thing we know about rationals, if we want to actually get the graph in here, is that we could have horizontal asymptotes. This is bottom heavy, okay? And if it's bottom heavy, I have an asymptote at y equals 0. So remember, you have top heavy, bottom heavy, tied in degree. That sound familiar? Okay, top heavy, we don't have one. It could be a slant asymptote. Bottom heavy, it's y equals 0. Tied in degree, it's the ratio of the leading coefficients, right? And so that means that if I have an asymptote here, and I know that coming from the left, I'm going to negative infinity, and coming from the right, I'm going to positive infinity, then the rest of the graph has to look like this. And that parent function is your rational parent function that looks like this. And then all we did is shift to the right 3. Okay? Now, does our limit from the left, is it the same as the limit from the right? This is our limit from the left. Is it the same as the limit from the right? No. So overall, it does not exist. Notice that on none of these 3 do I have an equal sign. If you put an equal sign, scratch it out. Don't erase it. Mark it out so you remember that you put it and then that you weren't supposed to, and maybe you know what I mean? I think it'll kind of help you note-wise. Okay, because we can't equal infinity. We can't equal does not exist. That doesn't make any sense. Okay, we good with that? Okay, so let's look at this next one. Do we have an asymptote here? Where's our asymptote? At 3. It's in the same place, right? So we have an asymptote at 3. Where's my horizontal asymptote? Y equals 0 again, right? Because it's still bottom heavy. And if I just straight up substitute in 3, I'm going to get 1 over 0. So when that happens, when I get does not exist, I have to look at the left and look at the right. Okay, technically, this is a ratio, so I should write it out as 2, but we'll skip over that part right here because we can't cancel anything out. So I would have the limit as x approaches 3 from the left of 1 over x minus 3 squared. Then I will also look at the limit as x approaches 3 from the right of 1 over x minus 3 squared. Okay? So let's think about this. If I substitute in this 2.9 or whatever like I did before, if I do 2.9, because I'm coming from the left-hand side, 2.9 minus 3, that's a negative number, right? But then you square it, so what happens? It becomes positive, so this is infinity. I put in 3.1, I subtract 3, it's positive, I square it, it stays positive, it's infinity. So that means on either side of this, it has to look like this. So my function looks like this, because I can't have any negative y values because I squared everything, right? So then, does the left equal the right? Yes, even though technically infinities don't equal. But then overall, then, my limit is infinity. Okay? All right, so key concept that we must address when finding the limits that result in a number over 0 is knowing if we're dividing by 0 from the left or 0 from the right, or a positive or negative 0 type of thing. So as we come together to whatever's creating the 0, if the sign's the same, either they're both positive or they're both negative. So if the sign of the 0 stays the same, which sounds weird about a sign of 0, then your answer is positive or negative infinity, because that's what just happened right here, right? And if it changes like the first one, then it does not exist. So straight substitution is great, but remember, if you do straight substitution and then it does not exist, you have to look at the left and the right, and then straight substitution may not work again. If we can't factor it, we got to think about the parent functions, and knowing what these things look like can be very, very helpful. Okay, we all good with all that? Questions? Okay, so now I want you to go back to the board and do the example on the top of the back. Erase what you got and do that one. So let's look at what we've got. In order for us to determine all of our asymptotes, I think you all pretty much started off the same way with your factoring, okay? So this isn't even as a limit statement right now, it's just a function. So let's take the function, so f of x is equal to, and then I can factor it. The numerator is going to factor into x plus 4, right? And then x minus 2. And then the denominator, x plus 2, x minus 2. I think we all kind of agreed to start there, right? Haven't even written it as a limit yet. Totally fine. So can I simplify this? Yes. All right, so I can cancel this out. So this means then, what does this mean I have? A whole. I have a whole at x equals 2. I know I didn't even ask that, but I want to make sure that we're writing down what we know, because that's still an important thing to know. Okay, I have a whole at x equals 2. I don't know, it's not necessarily at 2, 0, but it's at 2. I would substitute it back into the reduced form to figure out what my y value is. I guess we can do that. So the ordered pair, just for the heck of it. This would be 6 over 4, which is what, 3/2? So that's where my whole is, if we needed it. We don't really need it for what we're doing, but again, just talking here. So this is what I have it reduced to, which means I have a vertical asymptote. My vertical asymptote, how do I write a vertical asymptote? What is it on my graph? How do we graph it? What does it look like? This is not a trick question. What does it look like when you do it? A line. So it's a line, right? So we have to write an equation, a dotted line, but it's a line, right? So we have to write it as an equation of a line. So my vertical asymptote is at the vertical line, x equals what? -2. Lots of you had it at 2. Some of you had it at 2, and even though you had it solved right, then you had a brain fart. It's okay. But why don't I have 2 vertical asymptotes? because I canceled that out. When I factored it, it looked like it, but I actually, since I canceled it out, that became a hole, so I have a hole in one vertical asymptote. That makes sense? All the rational stuff coming flooding back? Yeah. Because it's the zeros of the denominator. It's because my denominator being 0 is what gives me that vertical asymptote. So to solve it, I put x plus 2 equals 0, and then it gives me that. Okay? We all good with all that so far? Okay, so then it says to determine all the vertical asymptotes and the behavior of the graph to the left and right of each vertical asymptote using limit statements. So here's where I want to do the limit as x approaches -2 from the left of x plus 4 over x plus 2, and the limit as x approaches -2 from the right of x plus 4 over x plus 2. Now, like I said, we're not going to get the entire graph on there, but let's talk about a couple of things. We have this here at -2. We have this vertical asymptote, right? And then we have a hole at 2 3/2, which means nothing for what we're doing, but there is a hole there somewhere. Let me make it a little bit higher. What about the horizontal asymptote? Where's that? I heard y'all discussing. It was good. Y equals 1, because it's tied in degree. Very good. So here at 1, I'd have this horizontal asymptote. Oof, horizontal asymptote, something like that. That looks horrible, but you get it. So on either side of it, I'm either going to infinity or negative infinity. I just have to figure out which one, right? If I'm coming at -2 from the left, -2 from the left would be like -2.1, right? So if I had -2.1 plus 4 over -2.1 plus 2, that would be positive over what? Negative, which makes it negative overall, so that's your negative infinity. And then if I'm coming from the right, that would be like -1.9 plus 4 over -1.9 plus 2. And then that's going to give me positive over positive, right? Which gives me infinity. So from my limits, I know that my function has to look like, coming from the left, it's going down here. I have no idea where it crosses or anything, but something like this and something like this, right? There could be other things happening that we didn't investigate, but it's really just asking you right around the asymptote what's happening, which way we're going. Okay? We good? So you wouldn't necessarily have to write this part down every time. I mean, you can kind of think through it. Like if I use 2.1, that'd be positive over negative. Like it can be a thought process, but I'm writing it down just because I don't want to lose you. I want it to make sense. Okay, we good on all that? What questions you got? Y'all had good discussions. I know we haven't really talked about the rational stuff. We've seen how much we could get out of the back of our brains, and y'all talk about it. It's good. All right, so now it says, remember, knowing the parent functions can simplify our problem significantly. Natural log. What does that look like? What's a log the inverse of? Can you at least tell me that? What do logs always go? What do they go with when we talk about them? There's base and powers, right? Because it goes with your exponentials. Exponentials and logs, you can rewrite them as each other. Do you know what an exponential graph looks like? Okay. Your exponential graph looks like something like this, right? So every inverse is reflected in the line y equals x. Means when we do that, if it looked like this, now it looks like this, right? That's basically what your natural log looks like, okay? So if that's my parent function, this is the parent function. Nothing happened to it. It looks something like this. So as I approach 0 from the right, what's my limit? Negative infinity. As I approach 0 from the right, there's an asymptote there. My answer is negative infinity. There's no work, really, that you can do. You have to know what it looks like. And if you can't think of log connects to exponentials. I know you know what an exponential looks like. Think about the reflection. That's how you can get there, even if you can't get there initially, okay? Tangent. First of all, what's the tangent of pi halves? Undefined. Okay. Tangent of pi halves is undefined. Very good. Okay. So let's say that, so if it's undefined, we have an asymptote here, right? And you know that tangent kind of looks like a cubic, right? And if you're not sure which direction it went, okay, so let's think about this. There's pi halves. There's an asymptote. This halfway would be pi what? Fourths? Okay. Is the tangent of pi fourths just, is it positive or negative is really all you got to think. Even if you don't know what it is. It would have to be positive because it's in the first quadrant, right? Everything is positive in the first quadrant. So that would mean that it has to look like this. Oy, goodness. It would have to look like that because it'd have to be positive, right? And then if you know it kind of looks like this, then it kind of looks like this, and there's tangent, right? Over and over again that we did. So as I approach pi halves from the left, what's my answer? Positive infinity. As I approach pi halves from the right, what is it? Negative infinity. As I approach pi halves, what is it? Does not exist. You see how you can reason through it? Okay, if you don't remember exactly. You know enough. I promise you know enough, or I wouldn't be asking you without just teaching you straight up, because I know what you can and can't do. All right, let's look at this last one. We have time for this last one. We'll talk through it together. So we have a vertical line. X equals 5 is an asymptote for the graph, okay? So I'm a visual person. I got to think, okay, here we are at 5. Probably shouldn't be the same color because I can't. So the limit as x approaches 5 is 0. Well, if this is an asymptote, do you think that my limit as x approaches 5 can be 0? What is it? It has to be what or what? Positive or negative infinity, right? Like, well, it's either this, right, or that. So one of these two right here could totally be true, right? It's asking me about false, so I'm thinking these are not my answers. So then I have these two left to decide which one has to be false. Okay, we don't know for sure what's happening here, but it has to be false. This says the limit as x approaches infinity is equal to 5. What would that even, what is that even talking about? Do you remember those? Remember our in behavior? As x approaches infinity, way out here, if it's approaching 5, what do I have to have on my graph? A horizontal asymptote. Very good. I'd have to have a horizontal asymptote, and then let's say that that's like at 5. I mean, I don't know what my graph looks like, but that could happen, right? I could, as x approaches infinity, the function could approach 5 or could equal 5, but could the limit as x approaches 5 be 0? It can't, because it has to be one of these two, right? Because if you're at an asymptote, you have to go either way, so that's what makes your answer A, right? Just want to make sure you understood that part too. We good? Y'all are awesome. Go ahead and tape that in.